Yeah, I'm looking for any partial credit in the work. That's part of. Yeah, I went back and fixed that last time, Ryan. I don't think so. It should work, but as things happen, I set those I set the parameters, and then oftentimes when you guys take it, I learn how well those parameters worked. So, and then hooking it up to the problem. Okay. All right. So we're going to do section 9.1 today. This is solving the quadratic equations. Specifically, we're going to use the square root property. All right, so a quadratic equation is an equation of the form ax squared plus bx plus c equal to 0. A, B, and C are real numbers, meaning they can be any number, but A cannot be 0 because I have to start with an x squared. Okay. We have solved these before. By factor. Right? For example, we've taken an x squared minus x minus 6 equals 0 and factored this x squared minus 3x plus 2x minus 6, where we factored it using grouping to get an x minus 3, x plus 2 is equal to 0, to know that x could be a 3 or x could be a negative 2. We've also done it when we've had the difference of squares. If we've had something like maybe an x squared minus 25 is equal to 0. We've got a perfect square here and a perfect square here. And we've said, okay, this could be an x minus 5 and an x plus 5. So x could be a positive 5 or a negative 5. So everything we did in chapter 6 is factored. What we're going to start talking about today are some of the other methods that we can use to solve quadratic equations. And one of those is the square root property. The square root property says for any non-negative real number C, if x squared is equal to C, then x could be the square root of C, or x could be the negative square root of C. We often write this as x is equal to a positive negative square root of C. If you have not seen this plus or minus notation, this is called a double sign, and we simply say it as x is equal to a positive or negative square root of C. Okay, so some examples. Here we have an x squared minus 21 is equal to 0. This can be rewritten so that we add 21 to both sides, and we get x squared is equal to 21. And now when I take the square root, the square root of x squared is just an x, and I will get a positive negative square root of 21. I have to simplify that square root of 21, but as I look at 21, that breaks into a 3 and a 7. And since I don't have any doubles here, I can't pull anything out of the square root. So it's just x is a positive negative square root of 21. Here I have a b squared is equal to 54. It is already of the form something squared equals something else. So I'm just going to take the square root of both sides. And here I have b is equal to a positive negative square root of 54. Can the square root of 54 be broken down? 54 is 9 times 6, and 9 is 3 times 3. Since I have a double here at 3, this would be plus or minus 3 square roots of 6. This simplification, Ryan, this is the part you missed. Yep. How to work those simplifications is what you missed yesterday. You can do 2 and 3, but they're not doubled up. We're looking for doubles because that's what square roots are, right? The square root of 25 is 5 because it's 5 times 5. So we're looking for factors that doubled up. Okay, try another example. Make this one a little bit harder. Okay, here I have 5m squared minus 4 is equal to 6. In order to get the m squared alone, I'm going to add 4 to both sides. Yes, I'm always trying to isolate the m squared. Now, keep in mind, I recognize that I can do this because it's not a trinomial. There's no like m term. And I'll show you that in a second here. So now the 5s will cancel. And I have m squared is equal to 2. And then I can take the square root of both sides. And m is equal to a positive negative square root of 2. The positive negative? Yeah. Remember, as from the beginning, this is degree 2. So I'm looking for up to 2 solutions. And in the case of the squares, that's often a positive and then a negative, same number. Yep, that's one way to do it. All right, x squared plus 25 is equal to 0. Here I'm going to subtract 25 from both sides. But there's a caution here. I know Summer should know it. I don't know if you will, Ryan. What do we say about the square root of a negative 25? Summer? Nope, it's not going to be negative 5. Because if you do negative 5 times negative 5, what are you going to get? You're going to get a positive, right? You cannot take the square root of a negative number. It is imaginary. So this one is no real solution. Ran out of room. All right, here I have a 3a squared minus 2 is equal to 21. So in order to get the a squared alone, I'm going to add 2 to both sides. 3a squared is 23. I'm going to divide both sides by 3. A squared is just 23 over 3. I'm going to take the square root of both sides. A squared, or whoops, not a squared anymore. A is going to equal the square root of 23 over the square root of 3. Now, here's the thing. You cannot divide by a square root. See how I've got that square root of 3 in the denominator? I cannot leave that there. So we use a little math sort of magic, and we multiply both the top and the bottom by the square root of 3. Keep in mind, this is the same as multiplying by a 1. Right? Because what is the square root of 3 over the square root of 3? It's just a 1. But what it does is it takes the square root out of the denominator. And I forgot what you always did here, Summer. Plus or minus. Just that same thing that you always said you forgot. But it's the square root of 3 times the square root of 3. which would be the square root of 9. And what's the square root of 9, right? There you go. Correct. Because I don't have the square root in that denominator anymore. Okay. All right, now we want to solve equations of a slightly different format. We're going to take something like x plus 4 squared, and we're going to set that equal to, I'm going to say an 81. Now, you can FOIL this, right? This is x plus 4 times an x plus 4 equals 81. I can get an x squared plus a 4x plus a 4x plus a 16 is equal to an 81. I can do an x squared plus an 8x plus a 16 is equal to an 81. Then I can subtract the 81 over. X squared plus 8x minus, what's that going to be, 65 equals 0. I can do what numbers multiply to give me a negative 65, add to give me an 8. It's an x squared plus 13x minus 5x minus 65. X plus 13 minus 5x plus 13. Woo! X plus 13, x minus 5, and x could be a negative 13, or x could be a positive 5. This works. Right? I mean, I've got 1, 2, 3, 4, 5, 6, 7, 8 lines of work, but it worked. I got there. There's an alternative method. Is x plus 4 a perfect square? Do you see how it's x plus 4 squared? And I'm squaring that entire set of parentheses equals 81. What if I just took the square root here? The square root of x plus 4 squared is going to be x plus 4. The square root of 81 is a positive or a negative 9. So x plus 4 would be equal to 9, or x plus 4 would be equal to a negative 9. Oops. giving me x is equal to 5 or x is equal to a negative 13. Do you like how much faster that second method is? I do. Are you catching up, Ryan? Is that what you said? Mm-hmm. But do you see how this second method is a lot faster? It's very specific, though. That's kind of the hard part about it, is you have to have a perfect square on this side. So let's try a couple more of those with some bit of variation. How many pages? My notebook, I've got like 2 pages left in my notebook. Are ya? I'm nearly done. Okay, what sample number am I on here? Okay, 7, I thought. All right, so same idea here. I've got a perfect square on the left side, so I can take the square root of both sides. X plus 3 is equal to a positive negative square root of 63. Can you simplify the square root of 63? That's the problem. X plus 3 was squared. If I take the square root of that, I'm going to be left with just x plus 3. The square root of 63 is a positive or negative square root of 63. 63 breaks down, I can do 3 times 21, and 21 is a 3 times 7. So if I break down 63, I have a pair of 3s and a 7. So this is a positive negative 3 square root 7. So my x would be a negative 3 plus 3 square roots of 7, or x would be a negative 3 minus 3 square roots of 7. These would be my exact answers. Now, if I need the decimal approximations, I do negative 3 plus 3 square roots of 7, which is what, about a 4.937? Negative 3 minus 3 square roots of 7. questions on that? Yeah. Plus, yes. Okay. So you understand this, the x plus 3 is equal. Now you see it? There you go. Plus or minus 3 square roots of 7. So I do the plus first, and then I do the minus. It depends. This shows your two distinct answers, that it's not one number, but two different numbers. And to start out, I would do it as two distinct numbers, so you don't start thinking of this as one answer. I plugged it into a calculator. -3 plus 3 square roots of 7. -3 plus 3, and then I use my square root button. It's in the first column. Shift x squared on my calculator. I put the 7 in and close my parentheses. Then I hit enter. If I go up to it and highlight it, I can now change that to a minus and hit enter again. Or you can retype. It doesn't matter. What did you get? Okay. That means you probably hit -3 or -3 -3. Make sure you're hitting the subtraction sign when needed and not a negative. Yes. Okay. All right, let's try another one that's similar to it. All right, so if we try a 5a minus 2, that quantity squared is equal to 3. Like the others before, I have a quantity being squared equal to another quantity. I'm going to take the square root here on both sides. The square root of 5a minus 2 in parentheses squared is just a 5a minus 2. This is going to equal a positive negative square root of 3. The square root of 3 cannot be simplified. So I'm going to add 2 to both sides. And I now have 5a is equal to 2 plus or minus the square root of 3. In order to get my a alone, I still need to divide by 5. And what I do on the left side, I will have to do to the right side. So I will have a is equal to 2 plus or minus the square root of 3 all over 5. This means that a is equal to 2 plus the square root of 3 over 5, or a is equal to 2 minus the square root of 3 over 5. This is how we would write our exact answers. To do the decimal approximation, I would type in 2 plus square root of 3. That's my entire numerator. So I would find out what that number is. It equals, then divide by 5. And I get a 0.746 approximately. Then I would do the second option, which is 2 minus the square root of 3. Find out what that is, then divide by 5. To get about a 0.054. Those are your decimal approximations to 3 places. Questions in there? Okay. What about solving let's say, let's do a 3x plus 7 squared is equal to a negative 20. What's going to happen here? Good, Ryan. When I take the square root of both sides, I again have the square root of a negative number. That square root of a negative number cannot happen, so we have no real solution. Square root of a negative number is imaginary, which is something you'll learn about in intermediate algebra, but we'll get no real solution there. Okay. Last one, or maybe two if I can get to it. I would say this is a special case. And it's almost a little bit of a trick question. Look at the x squared minus 10x plus 25 on that left-hand side. Do you notice anything about that trinomial? Ignore that bit for a minute. This left side is a perfect square trinomial. So when I factor this out, I'm going to get an x minus 5 squared. Right? Just like you were saying, Summer, x squared minus 5x plus 25. And that'll factor to an x minus 5, x minus 5. So this is an x minus 5 quantity squared. So now I can take the square root of both sides. And then I can add 5 to both sides. Well, I don't know. It depends. Sometimes they ask for exact answers, and sometimes they ask for decimals. So I'm making sure to offer you both when we do the examples. So if I had to do 5 plus square root of 7 as a decimal approximation, I'm going to do 5 plus square root 7. Then I'm going to do 5 minus. So this guy is exact, and this guy is 3 places. Or 5 minus the square root of 7. There should be 2 answers. Summer, is your battery dying? Okay. No. That usually has to do with connections. Probably just means Blackboard's a little overloaded right now. This, yeah, that symbol means approximately. Um, Basically, that particular symbol is used to say I rounded when nobody told me to. So if there aren't specific instructions to round, and as the person doing the problem, you decide to go ahead and round, the squiggly is just sort of a shout out to say, hey, I rounded this. Because exact means exact. All right. I mean, that's up to your boss, but yeah. If your boss says, hey, it's okay. I mean, people approximate all the time. It just sort of depends. Um, I have I have a story I tell about building a circular pond in the backyard. And the guy who brings in the rock that's going to go around the outside, he uses, for instead of using pi, he just uses 3 because it doesn't make any difference to him. He's handling big rocks, right? But the guy who's doing the Pyrex piping, he's got to use 3.14 because he measures down to a much smaller level. Yep. So, yeah. I mean, they can't have a gap because their work is so precise, right? So, so that's the precision you need is dependent. All right. Questions for me on this stuff? No? Okay. That's what I had for today. Tomorrow we're going to complete a square, which is a little bit different, but we'll work on that tomorrow. It's Wednesday. This is due Friday. All right. Okie dokie is it. I know. Yeah,